Hey everybody, welcome back. So today we're going to be talking about tangent. Now I know we've talked about tangent a little bit over the past couple of videos and a little bit when we started trig, but it's worth talking about this in a little bit more detail. So tangent is a trig function, but it's very different from sine and cosine. So recall from last video, we did define tangent as sine divided by cosine. Okay. Now remember from the very first video, or at least one of the very first videos, remember we cannot divide by zero. That's one of the golden rules of mathematics. Let's actually spell cannot correctly. Cannot divide by zero. And remember, cosine is zero, okay? Every time we're at pi over any odd multiple of pi over 2. So what's happening with tangent is we're actually blowing up whenever cosine is zero. So one of the first differences, remember sine and cosine both have domains of all real numbers, right? But tangent has a more complex domain. Its domain is all angles theta for which cosine of theta is not zero, okay? Because when it is zero, that denominator is going to be zero, okay? And we're going to blow up. Another difference, remember sine and cosine both have ranges of -1 to 1, right? But since we're going to be dividing by cosine and we're blowing up at some places, it's actually giving us a better range in some ways. The range of tangent, as we'll see in a little bit, is actually all real numbers. Okay, so in terms of domain's a little bit more complicated, but its range is actually really, really nice. Okay. Now, before we go to the graph, I want to comment really quick, how do you use the unit circle for tangent? Well, remember, in the unit circle video, we defined tangent of theta as the y-coordinate divided by the x-coordinate. So if we go to our unit circle, okay, how would you evaluate something like tangent of, let's say, 30 degrees? Okay, what you would do is you would take the y-coordinate and divide it by the x-coordinate. So in this case, that would be 1/2 divided by square root 3 over 2. Remember, if you divide by a fraction, it's like multiplying by the reciprocal. So we would get 1 over the square root of 3, or if we rationalize the denominator, that's square root 3 over 3. Okay, so if you're using your unit circle and you want to figure out what a tangent is, again, you identify whatever angle you're looking at, look at the coordinates, take the y-coordinate and divide it by the x-coordinate. All right, let's look at the graph. Okay, so here's the graph of tangent here. And again, notice very, very different from sine and cosine. In fact, it's almost like it's repeating the cubic function over and over and over again. Now, I want to show you guys that we do have vertical asymptotes here. So notice at pi over 2, which is over here, okay, where cosine is 0, notice we do have a vertical asymptote. In fact, we have a vertical asymptote at every odd multiple of pi over 2. So negative pi over 2, 3 pi over 2. So because we're dividing by cosine, we're getting all of these vertical asymptotes whenever cosine is 0. Okay? Now on the flip side, though, if you look at the range, notice that since we are blowing up, we're going, at least let's look at this first cycle here. We're coming from -infinity and going all the way up to infinity. So our range is actually very, very nice. Okay? Another thing to notice, the period of tangent is different from sine and cosine. Okay? So take a second, and I want you to look at that first cycle between minus pi over 2 and pi over 2, and think about what is the period of tangent. Okay, so hopefully you are getting the period of tangent is actually pi, very different from sine and cosine.